Let us first of all try to understand what is the role of civil engineer. As a civil engineer, you have to plan, design, and oversee the construction activities, and ultimately, if required, any maintenance of building, that is any structure and infrastructure. Now you can see in the right side there is a building under construction and various components of the building are rightly visible. Now if you see, this is the slab portion, this is a beam, this is another beam, this is another beam, and these are the column. Again this beam joins between two columns. So column is a vertical member and beam is a horizontal member. Beam supports slab and column support beam, and ultimately through this column we are transferring whole load of the structure to the foundation. That is, superstructure load is transferred to the substructure, that is foundation. Here you can see staircase. So this is a RCC building, that means reinforced cement concrete building. And in another figure, figure number 2, you can see there is a very interesting and good looking steel structure. So that means in a civil engineering field, most of the time we will encounter or we will come across the plan design and construction of RCC building or steel building. Now very first step is planning. Planning mean, let us say you are given a plot and a plan to construct a residential building or a commercial building, any type of structure. So very first step is you have to plan. Plan mean where you will be installing, or you can say placement of the columns, footing, or other component of the structure. Then another important aspect, that is design. Now later on we will be going into detail what is the actual meaning of designing, but for the time being we can understand that each component of the building need to be designed. Now you can see this is a column, and design of column mean you will be deciding the type of the material, cross-sectional area, and other components of the structure, that is beam. Now what should be the cross-section area of beam, what should be the material, whether it is concrete or whether it is steel. If it is concrete, then what grade of concrete, what should be the properties of concrete. All these taking into consideration, we will work out the cross-section dimensions as well as the steel, that the type of steel or what should be the area of steel which is going to be used in case of beam or a column. So all these calculations, these workouts come under the field segment of design. Then execution mean after planning, after designing, now you came across the execution of the work. That means now the building will be under construction and you have to supervise all the construction activities so that the plan and designing both should be constructed as per actual requirement. So after that, when building will be under use, that means it is going through its service life, it will be subjected to the purpose, the loads, all type of requirement of the building, and later on there may be some damages or building will be behaving and you have to maintain the building, you have to do the maintenance of the structure as per the requirement. Now designing of a structure, that is very important component of the in the life of the structure. That means what is the meaning of designing basically. Very first step is analysis. Analysis means you will be first of all going through all the details of the material of the, suppose if we are talking about the column, then you have to consider all the details. What should be the what are the dimensions of the column, what are the cross section dimensions, what will be the support conditions, what type of loads are coming on the column or any structural element. It may be beam or it may be a slab. Accordingly, when load is placed on the beams or columns, then how the column will behave, how any structural member will behave. Will it bend? Will it crack? Etc. So accordingly, you have to do the calculation, and that all the details will come under the analysis part. That means you are, before going to construct a building, prior to construction and prior to designing, you are very much aware about the various type of stresses or behavior of the building in totality. So that will come under the analysis part. Then in designing, after analysis, you will work out the dimensions of the each component of the structure, and ultimately after that you will be applying various checks. Various checks will be according to Indian standard codal provisions, whether the component, whether the structure is following all the guidelines of the Indian standard code, whether the column is going under various type of stresses, whether these stresses are within the permissible limit as recommended by Indian standard code. So these various checks you have to apply. And when we talk about the analysis, as a civil engineer, our role is to design a safe as well as economical structure. That means structure should be safe throughout its life, whatever be the life plan you have decided. Normally in case of RCC structure, we plan the structure should remain safe for its service life, which is approximately considered nowadays as a 50 years. So that means you have to do the analysis, you have to do the designing, all the parameters, execution, so that your structure should be safe, as well as you can't ignore the economic part. So that structure must be economical also. Now very important aspect is safety and economic aspect of the structure. Before going through all the details, we must be aware about what are the possible causes of failure of a structure. Now we are talking the structure should be safe, and before deciding the safety of the structure, we must be aware what are the possible reasons or causes by which the structure can fail. So that means possible causes of failure of a structure we have to consider. Then how to design a structure to address these causes. In first step, you will be just judging that these are the possible regions of failure of a structure. Now in the designing part, we will be trying to design the structure such that all these regions, all these causes should be taken into consideration, so our structure should be safe. Then how a structure behave when subject to loads and other effects. So that is very prominent part of the any structure, and in this subject this subject will be directly related to the behavior of the structure. That means in this subject we will be able to understand that when a structure is subjected to loads, then what will be the effects of all these type of loads and what will be the response of the structure. Whether there may be one response when you are applying load on the structure, then cracks may occur. That is one type of failure. As we have discussed possible causes of failure, some of the failure causes we can list here, that in cracks. So if cracks are occurring in a structure, suppose your beam is getting cracks, some cracks, then we have to think upon what are the possible causes of crack. When crack can occur, what are the various type of cracks? Now you can see in this figure number 1, that diagram we have taken from some sources. You will be finding there are some cracks very much visible. These are the cracks, some cracks, some are the structural cracks, some are the only cosmetic cracks. That means some of the cracks are only visible and extended to the surface of the structure. They are known as surface cracks. Maybe they are not so much dangerous, but if the crack is penetrating inside the element, that means inside the component, then it will be very dangerous. Because if it is a RCC beam, if cracks are of great width, that means you cracks are responsible that the steel inside the that beam may be exposed to the weathering actions. So corrosion or other type of things can happen, and which will ultimately unsafe the structure. So one of the effect is cracks. Then there may be crushing. You will be able to see many structures which are crushed under the load. Maybe some column are getting crushed under the load. Now you can see here, there is a column, and you will see that the material of the column, that is concrete, is not able to resist the various type of forces when load is coming on the structure. So it can crush, it can bend, etc. So later on we will be trying to understand all these things. There may be bending, buckling. Beam can bend. Initially beam is a straight member. When it is subjected to load, there is the possibility that those loads can bend the beam. If there is a column, load can buckle the column, or there may be some type of twisting also possible. Now you can see in this structure, it was a steel structure. Now you can see here, you will find some twisting happened. So that means twisting can be one of the reason of the failure, bending may be one of the reason, buckling can also. So from these three figures, figure number 1, figure number 2, figure number 3, you find there are some cracks, some crushing behavior is there, some bending is there. And all these happen due to some forces, because load itself is a force. So when force is applied, or when load is applied, some stresses will develop. We will try to understand what is the meaning of stress. There may be change in shape and size of the structure when load is coming on the structure. So that may be one of the reason of the failure. So ultimately a structure can collapse, it can fall down, it can collapse. So these few reasons which we are trying to here elaborate there, that cracks, crushing, bending. So these may be all, may be the reason, maybe any one of the reason which will be responsible for the failure of the structure. So we have to understand all these type of things, all these type of happenings, and what are the causes of happening. If we are able to understand what are the causes of cracks, then during design we can take into consideration all those factors, and we can maximize the possibility of not coming any cracks. That means maximum possibility of avoiding the cracks, crushing, etc. So this subject is very important for all of you, because you will be understanding all the basic things, and which later on in your next subject, that is design, you can this type of knowledge will be very much helpful. Now here, if you see this fourth figure, this figure was actually a slab and a column, and you can find out that this column is getting punched out of slab. So this type of failure is known as punching.